Hi everyone, in this video I try to teach you guys how to use Excel to estimate logistic regression. And I believe before watching this video, many of you guys, if you have exposed to logistic regression model concept, somebody might tell you it's impossible to use Excel to do the estimation. But here I actually want to let you guys know we can. We definitely can use Excel to help us to estimate our logistic regression, but we definitely need to have a better understanding about the mathematical formation of this logistic regression in order to properly use Excel. Of course, if you already have some kind of statistical software like MATLAB, SAS, so they already have a built-in function, you can be very quickly to estimate. However, if you don't, also if you know some basic programming language like a Python, and you also can estimate it without go through the Excel. However, if you are not, you have no idea about Python, if you don't have the money subscribing like MATLAB or SAS, and if you only have the Excel as your option, the answer is you still can run the logistic regression to estimate your parameters. So before we move on to the Excel spreadsheet, and I want to give you a little bit of background about logistic regression. So the question here is, most of the students and the people who asked me, consulting with me about regression analysis, especially logistic regression, they will ask me why we cannot use linear regression model. We have to use logistic regression. So when we actually should use logistic regression. To answer this question, it's pretty straightforward. So the key here is your dependent variable. So your y variable, so the variable on your left hand side, okay? So if you think about my previous video, look at the regression analysis, we focus on the linear regression model, and then we talk about our y variable. So the y variable has always to be continuous variable, such as income, such as the score you gain from the tests. So we are trying to understand what are affecting your salary, so that the y variable is the salary. So the salary can be from 0 to any positive values. And then the independent variable can be your education level, your age, your professional. It's how those are help you to predicting your salary. So in those situations, we are using linear regression model. However, in the real world, we need to solve some problem. That is, we try to predicting something that is not continuous. So for instance, in college admission, and the student can be admitted or not admitted, and you want to build a model to predict whether this person can admit or not admitted. So you can see the outcome itself is not continuous, like your income, your salary. So it's actually going to be admitted, not admitted. It's the binary outcomes, right? Admitted, not admitted. So we usually call the outcome you are desire, like you being admitted at college, as success. So the outcome you are not desire, considered as failure. So you only have two possible outcomes, success and failure. So in those situations, you should consider use logistic regression. Okay, another example, passing a test. You either pass the test or not pass the test. So you try to predict how much whether you spend more hours. So whether you major in different things, it might help you to pass the test. So pass or not pass is your outcome you're interested in, you try to predict. So in that situation, you also should consider use the logistic regression. Okay, after you understand the logistic regression, I want to show you a few very important equations that is related to logistic regression, because like I said, it's a little bit complicated when you try to only use Excel to estimate logistic regression. And the reason it's complicated because we actually have no pre-built function in Excel to calculate to estimate logistic regression. We actually have to estimate from the roots. In order to understand the roots, we have to look at how our logistic regression is formed and how they are related to the equation you see on the screen. Okay, so on the screen, in the first equation, what I'm trying to show is help you to understand when we are trying to predicting, for instance, pass or not pass a test, or admitted, not admitted by a college, we are kind of trying to predicting the probability of that person pass or not passing a test, right? you have high chance. Larger probability means you'll have higher chance. Smaller probability means you'll have lower chance. So some people might say, wait a second, okay, you talk about probability. It is a continual variable, right? You are right. So the probability itself is continual. However, why the traditional linear regression model doesn't work? The traditional linear regression model have no upper and lower limits. So basically, if you are thinking using the traditional linear regression model to estimate the probability, so you might end up the value larger than 1 or smaller than 0. But everybody know the probability theory, understand the probability can never larger than 1 or smaller than 0. So therefore, we have to be creative. So this is a functional form we will adopt to predicting this probability. So the numerator here is the exponential, parenthesis, b0 plus b1 x1 plus b2 x2. And then here, I assume we only have two independent variables, x1, x2. Obviously, if you have 4, and it's a plus b3, x3 plus b4, x4, right? So you can add. So the numerator is exponential of your linear equation we saw in the linear regression model, right? And then divided by 1 plus exponential b0 plus b1 x1 plus b2 x2. So basically 1 plus, we repeat the numerator. Please do not spend time to memorize this equation. So the reason we adopt this functional form is because this functional form gives us a very nice curve. So this is 0 and this is 1, and the cell will be like that. So this function will have smallest value is approaching 0 and the largest value is approaching 1. So it satisfies our requirement for probability. So this is the functional form we adopt. So now some people look at this equation, they will say, oh my goodness, how can I be able to estimate the value b0, b1, and b2? Because once we know the value b0, b1, b2, we build a relationship between our independent variable and our dependent variable. That's the probability we try to predict, right? That would be great. So then a statistician came out of the way. So they defined this term called a Logit. So the Logit is a log odds ratio. So don't worry about it. I will explain what is log odds ratio pretty soon. But let's just say, remember this term is called Logit. So the Logit is magical transformation of the equation we saw above. So the logic, after do a bunch of transformation, we got left hand side becomes called a Logit. And the right hand side is literally is an expression of a linear regression model we saw in the previous videos. And the b0 plus b1 x1 plus b2 x2. Again, if here I'm assuming I only have two independent variables. And obviously you can add a b3 x3, b4 x4 if you have more than two independent variables. And so the Logit equal to the expression of the logic is exactly what we see in our simple linear regression model. Okay, now the next question. What is logic really means? As I said, it's called the log odds ratio. So actually it is equal to the natural log of the probability of success. Like I said, the success can be you pass the test, divided by 1 minus p, the probability of failure. So that means the opposite outcome. That it means the probability of you not pass the test. So this is how we define log odds ratio. However, eventually, when we are trying to estimating this outcome, we have an objective function. So we try to maximize something. Remember, in the linear regression model, we have MSE, mean square error. So we try to maximize we try to minimize the prediction error. But here we are trying to maximizing something. So let me talk about what are we trying to maximizing. Okay, so after we got understand what is logic, we have to understand what is odds. So the odds actually is equal to the exponential of the Logit. So basically, if we take exponential of the logic, we will receive p divided by 1 minus p. So that is odds to success. So that is called odds. And then we will be able to recover the value for the probability of success. See? This is like a whole loop. We try to eventually get in the value for probability of success. So the probability of success actually equal to odds divided by 1 plus odds. So why this is important? Because for each observation, we will be able to predict the probability. And we want to make sure this probability are as accurate as we can to approaching to our real outcomes. And so before we talk about our objective function for the linear regression model is try to minimize the difference between predicted value and the real value. But here we try to, instead of minimize, we try to maximize our predicted outcome with our real probabilities. So later, based on this probability, we are able to developing a new term called log likelihood, and we try to maximize that term by searching for the value of the B0, B1, B2. So the ultimate estimated value for B0, B1, B2 allow us to maximize that log likelihood. Okay, so this is the theory behind it. And if you totally lost, don't worry, because our ultimate goal is try to learn how to use Excel to do the estimate. So this part of the explanation is just try to help some of you guys want to know why we are doing what, right? So now let's move back to our Excel. Let me move back to my Excel. Okay. So in this Excel, I'm looking at to try to be consistent with the concept I explained on the whiteboard. And so I use this case, we also only chose the situation we only have two independent variables, GPA and experience. So we try to see how the GPA and the experience can be used to predicting the probability of passing a company tests. So we're thinking the hypothesis would be the higher GPA, the more working experience you have, the more likely you're passing the tests. And so we collect the data. So we went to so this is a hypothetical example, okay? So we went to a company and collecting, let's see, 260, let's see how many observations we have here. So we have 236 people taking these tests. So at the same time, we're collecting their high school GPA, and we look at how many year experience they have. And so we try to look at what's the relationship between GPA experience to the chance to passing the tests. And to answer this question, you obviously can see the y variable is not continuous because they're either pass or not pass. We're using the value 1 to indicating they pass the test. We're using the value 0 to indicating they fail the test. And so, great. So the first thing in order to estimate the logistic regression model is to adding a very important function to your Excel, okay? If you click your data tab, on the right hand side, you can see before we are using data analysis, now we're actually gonna use another one called a solver. So by default, you won't be able to see this solver on your Excel. What you need to do is go to File. After you did the File and move down to go to Options. After you go to Options, so it's very similar as how you add on the data analysis. Okay, exactly the same place. And you go find Add-ins. So click Add-ins. So once you click Add-ins, and on the bottom, you will see Managing Excel Add-ins, and you click Go. And then make sure you check the box called the Solver Add-ins. And then once you click that, check the box Solve Add-ins, and then you can click OK. Now you click the Data tab, and you will be able to see Solver. It's very important, very, very important. You need to have this function. You need to have this icon show up on under your Data tab. If not, you cannot estimate your logistic regression. Okay, after you got that, so what we will do is first, we are trying to estimating our Logit, okay, Logit. And then if you don't remember what is Logit, let's go back to my whiteboard again. Okay, so the Logit is equal to, actually is our linear equation, B0 plus B1x1 plus B2x2. So what we're gonna do is we are calculating Logit based on this equation, okay. Let me go back. So we will calculate Logit. So the Logit will equal to, don't worry, because I know here is empty, because later we're going to fill in some numbers. We can fill in some number, or even we can just leave it empty. So Logit is our y-intercept, right? And then don't forget, we're actually gonna log it. Find the dollar sign. Oops, sorry. So equal to intercept. So in my B2 cell, F2. So find the F2 on your keyboard, you push it, it will put the $2 sign in front of B and in front of 2. So that means we try to log this cell. Because the ultimate goal is we try to fill in the 263 values automatically. So basically we're going to drag it down. So without changing, we know this intercept always locked in that cell, so we don't want it to change. We only need to want to change the value for x1, x2. And then plus, called the sum product. So what is sum product doing is we are using one array times another array one by one. So in this situation, we want to use b1 times x1, b2 times x2. So what we will do is we select the first array, right? So the b1, b2. So each element in this first array will multiply by one with the second array. So comma, and then we select the second array. So in this situation, the C2 will multiply by B4, and the D2 will multiply by C4. So that is what this sum product will do. And then you can close parentheses. But like I said, we want to use the drag down function. In order to do that, you understand every cell will change unless you lock it. So as we drag it down, we want the B4, C4 to keep updating, but we don't want our C2, D2 update because that's the value for B1, B2s, right? B1, B2, so we don't want them to update. So therefore, do not forget to put the dollar sign. So move the mouse to the C2, push F4, and move the mouse to the D2, push F4. So now you lock these two cells, and then you push Enter. Okay, after you finish it, and we ask the Excel to automatically fill in the rest of the cells. So move your mouse to the right down corner, right, left, double click it, and it will automatically fill in it. So don't worry, it's 0. It's natural because my intercept, they're all empty. So if you don't like to see 0, let's just put some number in the y-intercept, put a -2 in it, okay? So now you see the changes, right? So now the next step, we try to get our odds. Okay, so if you don't remember what is odds, go back to this sheet again. So the odds is the exponential of your logit, right? Your exponential logit. So now we go back to, in order to get our odds, what we need to do is type in equal exp. That means taking the exponential and the parentheses, choose the logit, close the parentheses, and then push Enter. And we want to do the calculation for the rest of them. So move the mouse to the right down corner, double click, okay. So now we finished calculating the odds. So now the next step, we want to calculating the probability of the passing the test. So if you don't remember how we calculate in passing the test, go back to the whiteboard. So after we got log odds ratio, to getting our probability of the passing the test is equal to the odds divided by 1 plus the odds. So that's what we're gonna do. And we go back. So we type in equal odds divided by 1 plus odds, close the parentheses, and push Enter. And then we ask Excel to finish the rest by itself. Great. So this is the probability of odds. Now it's the tricky part. Like I said, our ultimate goal is try to maximize the likelihood to predict the answer correctly, right? At this point, we know the probability of the pass is 0.1192029, and then how that is matching our chance to passing the test. So we don't know yet. So what we're gonna do is we're using the if function. If the result here is equal to 1, okay, and then we will use the result we just predicted, probably with the pass, okay. Otherwise, it should use the probability of failure, right? So if it's not 1, so we should use the probability of failure. So the probability of the failure will equal to 1 minus the probability of the pass we just predicted. So that's how we are finishing our if functions. So again, one more time, if the outcome is 1, and we should use the probability of the pass we predicted. And otherwise, the probability should use a failure, so it will be 1 minus probability of the pass. Got it? Very good. So we push enter, and we are using Excel to finish the rest for us. Okay, so basically, in the first example, the probability is 1, and then we are using the predicted probability is 0.11, and the second one outcome 0. The predicted outcome probability correction is 0.000797. So you can see we have higher chance to predicting. You can see the probability we predict is 0.11 is very low chance, and so the correction. So when the outcome is 0, so the chance for us to be correct is 88% correct, because 0.111 is very close to fail, and it's very likely to predict it 0 correctly. But when we have outcome is 1, and we still predicting 0.11, so the probability to predicting this outcome correctly is very low, is 0.11. Okay, so like I said, the ultimate goal is try to maximize, to have all of those predicting correctly at the same time. So we basically try to multiply all of them together. But if you know mathematically well, so if we try to multiply all the value together, so that means all events happen at the same time. So we try to maximize that outcome. Okay, so if that's the case, you can see it's impossible. It's a very small value, because all the probability we're predicting here is between 0 and 1. So any value, the more value you multiply by, the smaller the value is going to be. So you will never able to maximize this value. So then we're going to do a mathematical transformation. So what we will do is we actually take a natural log of what we just got. And then to do the rest of them, so this from probability correction to log likelihood, this is pure mathematical transformation. So the reason is to create something we can maximize, because the probability of the correction here we won't be able to maximize. So then the mathematical formula to equivalent to multiply by all the probability of the correction together. If you do the log transformation, instead of using product, we just use the sum. Okay, sum all those values. So this value we are trying to calculate in here is our objective function. Okay, we try to maximize this value. So this value currently is very small. It's a negative 275. It's a very small value. So now our goal is try to find the right value. So don't surprise, this, like I said, this negative 2 is a random number I put in it. So this should not be the value that can maximize our outcomes. But this is our objective function. So the sum of this is the log likelihood function. So we try to maximize this value by choosing the proper value of the B0, B1, B2. So that's how we estimate it. So we have objective function, we have our choice variables. So the next step, what we're gonna do is using Excel to help us to optimize the value, and then and also what is the highest log likelihood value we can get. So now that's where we're gonna use solver. And then we're gonna click solver. Great. So set up the objective. So since I selected H2, so they already put H2 as my objective. So H2 here is my objective. Great. And then what do I try to change in variable? So what is my choice variable? So that will be B0, B1, B2. So those are the value I try to changing them so that I can maximize my H2. So now I move on here, and now I will select my B2 to D2. After I do so, and also I don't have any requirement on the value of those B0, B1, B2, they can be negative. So therefore I will uncheck it. And before we move on to click solve, and I highly recommend you, because again, we are using nonlinear model, so don't change that, but click options, go to nonlinear. We want to increasing the more iterations, so we can increasing the population size. So basically how many iterations you want to go to 1,000. And then you can click OK. So after you click OK, and then let's click solve. Pay attention on my B2, C2, and D2. Remember, B2 is -2, C2 is nothing, D is nothing, and my H is -275. Now I click solve. Great. So you can see everything changed, right? So first of all, my objective function become much larger. Remember, -275 was my initial values. So after I do this maximization, and then my value changing to -149, so it's much larger than my initial max likelihood value, right? Log likelihood value. And the second part changed. Is the value for B0, B1, and B2, right? B0, B1, and B2. And then initially, intercept is -2, and B0, B1, B2 are empty. So what I'm showing you here is the final estimated value for B0, B1, B2. So that is how X1, X2 are related to the chance for a candidate to pass that test. Great. So the next, we still have a few more minutes. Again, I always tell people, getting the answer is one thing. Another important part is how you should interpret the result. So most stakeholder will have difficulty to understand what is log likelihood. So the most practical way I suggest my students is to look at the value, to look at the sign. So that's very straightforward. So if the sign is positive, so that means, for instance, the GPA's value is corresponding to 1.49, so it's positive. So what does that mean? That means as GPA increasing, and then the chance for the candidate passing the test is increasing. Okay, you cannot quantitatively to interpret this value yet, but you can give this directional suggestion. So as the GPA increase, the chance of the passing the test increase. And similarly at the work experience, so the partial coefficient for work experience 0.2, so that also means the more more working experience you have, the more likely you pass the test. So just look at the sign, you already are able to give a good interpretation. However, if you're really looking for the quantitative explanation, so what you need to do is you're gonna do two things. First, actually one thing, you need to use exponential. Take exponential of the, take the exponential and take the exponential. Okay. Okay. And then -1. And -1, sorry. Exponential -1. So what does this mean? So this means, so for instance, do the second one is easier. So the experience. So if the experience increasing by 1 year, okay, increasing by 1 year, so the odds for you to pass the test increase by 21%. Okay, if your working experience increased by 1 year, the odds to pass the test increased by 21%. Like I said, it's very awkward. If people have no idea what is odd, it will be really hard to understand the interpretation here. So that's why I usually advise people to focus on the sign instead of try to convert it. So for another one, 3.44, yes, it's really large. So that actually means if the GPA increased by 1 point, the chance for you to pass the test increased by 300 times. And some people say, wow, that's a huge value. So I totally agree with you. But if you think about for GPA, the high increase by 1 point of GPA is a huge increase, right? So it sounds like this one is a little bit unrealistic. However, what you can do is instead of increasing by 1 GPA, and you actually can decrease the amount of your partial coefficient. So now, instead of increase 1, it's increased by 0.1. So now our result changed, so it's more realistic, right? So in this situation is if your GPA increased by 0.1, and then the chance for you to pass the test increased by 16%, right? 16%. So there is some tricky way, and but here again, this video's ultimate goal is try to help you to understand how to estimate the logistic regression model. And then if you have any question regarding how to specifically interpreting the result, feel free to leave the comment below, because like I said, different case might have different tricky way to explain it. But if you are, like I said, if you're the audience have no idea about odds, so please just focus on the sign of your partial coefficient. Don't try to convert to what I just shown here, because it would increasing the difficulty of understanding the result. And so hopefully this video is helpful and help you to understand that actually we can use Excel to estimate logistic regression. It's very complicated. It's feasible. So good luck.